that that's our focus here. We have referenced the International Panel of Climate Change's 1.5 degree report of 2018, and also the sub-2 degree modelling that the International Energy Agency has done and released initially in 2018 and highlights, and of course the work that the EIB and development banks have been doing in this particular space. Europe has caught up with some of that in the meantime. Only late last year, the European Commission and member states adopted stronger targets, net zero carbon by 2050, which is fantastic, absolutely in line with the IPCC recommendations and something that every country in the world needs to adopt, and has adopted a strong 2030 target of 50% reductions in 10 years, critically important. Now, how that plays out in terms of European Union and member state policy, frankly, is yet to be seen. That's a work in progress, but this is part of that whole story. What we think we've done here is a procurement plan for the future, or a procurement plan for the Paris Agreement. We're in the middle of a crisis now. In the midst of this crisis, we have to start, well, we are beginning to think about what is involved in having a resilient society. Our health systems, according to the World Health Organization, IPCC, can expect to have many experiences of pandemics this century. As climate adjusts quickly and we get various kinds of climate shocks, heat stress, droughts, fires, much more extreme storms, all of those will lead to the kind of ecosystem dislocation that we know leads to increased pathogen experience, and some of those cross barriers, some of those lead to pandemics. The great pandemics that Europe has experienced in the past, for the last 1,000 years, have usually been associated with some kind of climate shift. So this is something to be expected. We have to learn now, while we can, about how we ensure we build greater levels of resilience into our economies, ecosystems, societies, and infrastructure. And that includes social protection measures, as well as health system improvements and so on, to be able to make sure that we've got a better chance of surviving future shocks. Those shocks will be a wide range of things. I note the weather-related shocks that we can expect to experience. Now, that's assuming we get climate, or at least emissions, under control. At the moment, those shocks are baked in. The 21st century will be a century of significantly increased volatility in our weather systems and consequent impacts than last century. What we're in a race to do now to meet the IPCC targets is to avoid catastrophic change. And that is very difficult for us to manage. That will make, unfortunately, the extreme circumstances of the virus we're experiencing now seem like a cakewalk. That's what we're going to race to do. That's why, if you like, the vaccination against catastrophic climate change has to be achieving that 50% reduction in emissions in 10 years. What we've tried to do here is to lay out a pathway with thresholds, with a taxonomy of investments that need to be made, which are consistent with achieving that change. Some of these things are things that are going to be there in 2050. We want solar, wind, renewable energies everywhere. But in a lot of areas, we have to achieve change. We've put in a threshold, which we consider the minimum to say you're in line with the Paris Agreement now, but that will tighten between now and 2050. In other sectors like manufacturing and building, this is a significant feature. In this sector, in a couple of areas, we'll talk about that. And then there are enabling investments as well. I'll stop there. Let's dive into and see what we've got here in terms of our criteria. So first, overall, we've set a technology agnostic threshold, Karsten. That's right. Explain to us what that means and what it is.
Thanks, Sean, for the introduction. So what we see in terms of production of electricity is that there's one threshold, 100 grams CO2 equivalent per kilowatt hour, for all kinds of different ways of producing electricity. And that is meant to be based on a life cycle emissions analysis, meaning from start to end, basically. That translates, maybe the slides can go back one, possible.
My apologies. I'm learning how to use these systems. I'm a trainee.
Good. Yeah, I think it's better. It's easier to follow. So what we see is that, and you see it on the left-hand side, that various technologies are mentioned here. There's a few of those where the life cycle emissions analysis is derogated for the time being. So that's the technologies that are seen as being below the 100 grams threshold. So you see yourself what those are. I'd like to highlight that see with solar and wind, so that's automatically in right now. There's some derogation for hydropower and geothermal, and ocean energy and CSP fall into the same bracket as solar PV and wind. So the product carbon footprint basically is what the life cycle emissions analysis is based on. In that respect, it's good news that not for all technologies there has to be a product carbon footprint assessment. Basically, what we see here is that certain technologies are clearly in, others may be. What the taxonomy regulation foresees is that solid fossil fuels are not part, cannot be part of the taxonomy.
So coal is out, right, according to the member state and parliament agreement entirely.
So yeah, that's the result of the political agreement. So that's stated in the regulation. So everyone can see that. What the 100 grams threshold means for natural gas is that without abatement, it's very unlikely that it's falling under the 100 grams threshold. With CCS, with carbon abatement, maybe. So that depends very much on the individual site.
So we've got a technology agnostic threshold, apart from the exclusion of coal, of 100 gram. John, can I ask you, can you explain what is this 100 gram? First, tell us what does it mean and how did we get there? People need to know why 100.
Yeah, the 100 grams effectively is the value we need in order to meet the 0% goal by 2050. If we start from today, where we have about a bit over 3,000 terawatt hours of electricity generated, consumed in Europe, and producing just over 1,000 kilotons of CO2 annually, if we look at today's Eurostat figures, and we know we want to get this value to zero by 2050. Effectively, 100 gram is starting from today for a typical new plant which comes on, assuming that it's going to be on the system for 30, 40 years maximum. Then effectively, this is the value it needs to have on average in order to follow this trajectory to zero by 2050.
Right, and
that's how we got it.
And we've got an explanation in some detail in the report if people would like to understand the rationale for it. But Karsten pointed out that there are many areas where we are excluding the requirement for a life cycle analysis to prove you're there. And then there are some places where we still need to do it. The reason we've excluded them is because based on current research, we're pretty clear that these technologies fall below the threshold, even accounting for production and so on. It's a life cycle view. And so rather than require every single issue to do it, we've said in these sectors, for the moment, you just are not required. That will be reviewed as the threshold tightens to 2050. We may need to reintroduce life cycle analysis for wind. It's a question mark for the future. But that begs the question, John, what is the life cycle analysis and how do you do it? Can you give us a bit of color about that?
Yes, this is something we're all developing at the moment because we haven't been doing it historically, at least not for all sectors. There are certain subsectors where the upstream or downstream emissions were significant where we've always done it. And the examples, and the most classic examples in the renewable space, have been hydropower, where you have a lot of emissions associated with the methane fugitive emissions during the formation of the initial reservoirs as vegetation rots, or biomass, where there's a lot of energy input that goes into certain forms of biomass that completely, although ultimately it's always wood and it's always a short life cycle, there's very different environmental and climate impact depending on the source of biomass you use, or whether you're actively reducing biomass, which would otherwise naturally be rotting and releasing methane into the atmosphere again. So these are the sort of upstream fuel. Then for some types of generation, and hydro again, there are huge quantities of emissions involved in the actual manufacture of construction. The cement that goes into a dam is an additional potential large source of CO2 emissions that needs to be factored in.
Mm-hmm.
So those are the types of things. Now, in a lot of cases, the transport may be significant, may not be significant, depends on the source that we're looking at. So we're looking at whole life cycle emissions involved in construction, the upstream emissions linked to gas or hydrogen production, same thing. If once you burn hydrogen, it's got zero net emissions actually at the point of combustion. But to produce the hydrogen in the first place, you need to look at what energy, what's the source, what kind of things go into it. So that's the thinking behind going for the full life cycle, and that's what we need to look at in order to capture the full chain of emissions and value.
So again, there's quite a long discussion within the full report, which is a 600-page report around life cycle analysis. And there may be some further work needed required to give people guidance in this area. As John says, as a world, we're learning. Unfortunately, we have not been listening enough to our scientists for the last 30 years. This is stuff we should have worked out a long time ago. There are methodologies, there are standards out there, but the application in some of these areas is still a work in progress. That's the lesson to be learned. But that doesn't stop us setting the threshold that we've done now. So a lot of people are asking about gas. It's quite clear, I think, John, that gas that's unabated is unlikely to qualify under this threshold. Is that correct?
Yes.
But
yeah,
if you have carbon capture and sequestration, which we'll come to a little later, you potentially could.
You could also, if you're having residual natural gas co-fired with eligible biogas and hydrogen, for example. And there are other ways to reach the 100-gram target. But it's very clear that the classical gas-fired generation and even classical gas-fired cogeneration will no longer meet these thresholds. These are, I mean, this is a shift in policy, and it represents a shift in policy in the European sector as well. When we were promoting large CHP everywhere, this was a time when we still foresaw a large role for gas going forward, and when the EU ambition was to reduce power sector emissions by 80% by 2050. We're now going much further. We're actually going to zero, and there simply isn't a large space for those types of gas industries going forward, certainly not in the final picture. There may be a room as a temporary measure to decarbonize in the very short term, but any investor who wants to invest in these assets needs to be very well aware that they're investing for the very much short term.
So folks, this is a change. In 2015, the common view was that gas would be part of the transition and was essential. And we still have many countries around the world who have in their climate change plans the ramping up of gas because of that understanding. But in 2018, we had two landmark reports which kind of burst this bubble. It was the IPCC 1.5 degree report and the IEA World Energy Outlook that year and their sub-2 degree modeling, which have said to us, yikes, the emissions we've been putting into the atmosphere for the last 30 years, which have until last year kept on going up, have meant that the reduction pathway we have to achieve now is so steep that, as Fatih Birol, the executive director of the International Energy Agency, said in November 2018, there is no room for new unabated fossil fuels to be able to achieve the Paris Agreement, if we want to achieve the Paris Agreement. And that's difficult. That is deeply challenging because every energy system in the world has been working on the basis that we would have a gas transition plan but the science has changed. And the lesson we have to learn from the last 30 years is we have to listen to our scientists, because we have too many times said, yes, that's right, we'll get there. In the meantime, we've got the economy to look after, whatever. Think about this as the same problem we're experiencing the virus. We tried in some economies to delay dealing with the virus, and the virus has gone utterly crazy. Where we've stepped in quickly with measures recommended by our scientists, the virus is more under control than in other places. And honestly, it's time for us to do with climate change as well. And that's what this taxonomy reflects. But it is challenging. Everyone knows it's challenging. The next step is now to start working with industry and government on how to make this work. Changes to energy policy are clearly going to be required now to do this. Karsten. One of the things about gas is the fugitive emissions issue, which is an extra clause we put in there. Can you tell us a little bit about why?
Yeah, happy to do so. And it links very nicely back to what John and you mentioned already. So it's a life cycle view that we have to take just by looking at the site where gas is going to be burned is just not enough, because we have certainly leakage, either at both at the well site where exploration takes place, and very likely during transport. So if we want to achieve the threshold and the overall goals, it needs to be taken in a holistic way. So in that respect, it's very important to look at it as from a perspective of a life cycle analysis. And that has to be proven as well. So it's not just about saying, okay, we know it's low or it's negligible. No, it needs to be proven. So what is very important in order to have the numbers available and to base actually qualification under the taxonomy on facts.
And that's something that has been, again, difficult to address, because this is challenging for the gas industry to do. BP has made a commitment to introduce life cycle analysis over the next 10 years across everything. Equinor is doing that. So it's not impossible. But, you know, we had another report a couple of weeks ago about unusually high methane levels in the atmosphere compared to projections. This is the 7th year in a row that methane has been way higher than what we expect it to be. We do know that a significant amount of that is coming from gas leakages in various places, whether it be in the Permian Basin in Texas or in Turkmenistan, to note two particular ones that we've seen. So unless we have confidence, then gas isn't as good as we thought it was, unless those leaks are tapped and measured. We can do this. Methane tracking can now be done by satellite, but we've got to act on it and move on it quickly and manage the process and report it, which is why we've put it in there. We've got a few other areas that flow out of this particular page. Nuclear. Everyone asks about nuclear. I just had one question say, why is it excluded? John, tell us what is actually the story of our recommendation.
Nuclear is complicated. We all know it's politically sensitive. We had a lot of discussions inside the group as well on nuclear. The conclusion that we arrived at is that nuclear's contribution to climate is definitely recognized as an expert group. However, the pollution issues, and particularly the long-term storage of waste and other issues that go with it, make it a non-sustainable way of meeting the climate goals in the long run. So this is a beautiful illustration of the taxonomy's five-pillar approach, where we basically, if you meet the criteria in one, say, you must do no significant harm in the other main sustainability pillars, and these include pollution in particular. And for nuclear, it was felt that there is no way, we have no sustainable way of managing the waste that comes with nuclear power. Therefore, it cannot be considered a sustainable activity. This is not to say that we do not recognize the contribution of nuclear in climate. And certainly when we reverse it, when we're not looking at generation, but at demand, for example, or we'll cover grids in a while, when we're looking at which grids are clean or which electricity is eligible if it comes from below 100 grams, then nuclear energy definitely qualifies. So activities that use nuclear energy to produce low carbon manufacturing products or biofuels or whatever is definitely an eligible activity.
And by the way, that's with a full life cycle analysis, even accounting for the concrete that's used there, because some people worry about that side of stuff. Our recommendation is not actually to exclude or include. Our recommendation, well, clearly saying it is low carbon for the purposes John has said, but it requires further investigation. We were not able to finalise that discussion on do no significant harm because it's very complicated, politically sensitive as well, and we've proposed that the Commission consider a future inquiry. We don't expect that to happen this year. It's in limbo. Let's just put it that way.
And there's other similar sectors which are also in limbo. I just see a question come in on waste to energy,
yep,
which is a hugely topical issue. And again, for the same reason, where one of the pillars of the taxonomy is circular economy, waste to energy can be an option in some large residual waste thing, but it was also felt in the waste discussion that it shouldn't be a first goal or first stepping stone to manage waste. You should first go via recycling and recovery. And this is why it's not excluded and it's not included either. It's a bit in limbo and it's been referred for future review by the expert group. Unfortunately, we covered a lot of sector in a very short amount of time, and particularly the more tricky ones, we weren't always able to get to a final agreement on. Is that right, Sean?
Absolutely right. Thank you. I'm going to now move on, if it's okay with the two of you, to the next slide, which is about electricity transmission and distribution. So I'm going to ask Karsten to introduce the principle first, and then John might dive in with some of the underlying methodologies here. So tell us what we're trying to do here, Karsten.
So basically, it's considering the importance of the electricity transmission infrastructure. So that's a starting point. It's sort of, let me say, enabling the transportation of power, say from A to B, and as such, it's a critical infrastructure for transporting, for instance, renewable energy. So how did we approach that? Say, basically, by default, the investments in grids are part of the taxonomy or qualify for the taxonomy under certain thresholds. So there's two of them. One is the grid emissions factor. So either it's below 100 grams, or that's the second alternative. It's 2/3 of new capacity added on a 5-year average to the grid. And then again, under 100 grams CO2 equivalent per kilowatt hour. So meaning that the power grid has to be on a declining path in order to showcase that it's actually delivering on the longer term goals. And to add to that, it's important to understand that there's a whitelist. I won't dive deeper on that right now with respect to certain parts that are relevant for such a system. Say like, for instance, equipment, control measures, charging stations that are in by default. So to make it really easy, what is excluded is the connection of fossil fuel-based power plants, for example. So as we had on the previous slide, that would not qualify because of obvious reasons, as far as I can tell. So there was not a big discussion about that. The center discussion, or the discussion centered around making the grid work as much as possible.
So we want to electrify Europe, so to speak.
Yep.
We're going to need massive improvements in interconnectivity and infrastructure for distributing energy around our member states, as well as the energy vendor within, or rather the links, north-south links within Germany and in many other countries, right? So John, tell us a bit about the underlying technology. We've kind of derogated in Europe, right? We've said Europe meets our broad threshold, but what is that underlying system? Because other countries need to understand.
Yeah. No, we didn't start with derogating Europe. Certainly the idea we had was to define, and we had a lot of discussions and saying, look, an electricity system is neutral in itself. It doesn't support or put barriers up to renewables, or fossil energy, but neither of them can function without a grid. So if we say we need to develop a grid to build renewables, that's a fair argument. But other people say, well, if you develop the grid, you're also facilitating the free flow of fossil energy and the sustained life of existing coal plants, which we actually might want to shut down. So we spend a lot of time thinking, well, under what circumstances can we actually say that a grid really predominantly supports renewables? And this is the fundamental argument here. And then we tested this in various European countries and the European system as a whole, and came up with this view that, look, in Europe, certainly we have a policy to thoroughly develop renewables, and we've been adding a lot more renewables capacity than fossil energy. So therefore, couldn't we not say that the European system at least is clean? And I think in general, the group then agreed, well, this is a good approach, but what should be a proper value, and how should we define on what is a good grid and what is a bad grid, or put it in simple, well, good grid or a grid which is not yet good. And then we came up with this view that given that most renewables are intermittent and have lower load factors than fossil, we need significantly more renewables than fossil capacity being added onto a system to make sure that we have more green generation entering the system than fossil generation, and combined with the natural going offline of traditional fossil generation, that then gets us to these values. So this 2/3 value is based on a lot of work that was done by our colleagues at the JRC, the Joint Research Council of the European Commission, which took a look at what's been happening in Europe and outside Europe as well in terms of addition. And then we agreed on, well, when we finally agreed, 2/3 of the new capacity being renewable seemed to be achievable, and also adequately reflected countries outside Europe which were making similar efforts, but countries which were making no efforts would not necessarily have been covered by this.
Exactly right. Now
and it was always important that the methodology applied outside Europe as well, and gave other countries or financing institutions in Europe a clear pathways for saying outside Europe, if you want to invest there, look, there's a relatively simple check. You look back for the last 5 years, if they've been adding significantly more renewables than fossil, then the system is on the right pathway and you can claim it as green.
And it is worth noting, for the last few years, more renewable capacity globally has been added than fossil fuel capacity. We have reached that tipping point already, but whether it works in a particular country will require a bit of analysis later. But this is a European focused taxonomy. A couple of people have asked about the international dimension. Let me use this point to say, we've come up with something specifically for Europe, but these are science-based criteria linked to a global trajectory of emissions reductions. And so broadly, we believe they are consistent for other countries as well. There are some areas where criteria are tied to a European metric or a European measure. In the building sector, for example, we've got tough new build because the new build mandatory regulation is already tough. But generally, we do think that these are global approaches that ought to be adopted if we are to be consistent in our view of listening to the IPC scientists and the other people working in different sectors. How these will actually play out, though, in different countries, we get to see. We only have the power and the opportunity to recommend within Europe. But of course, European investors will be reporting against this taxonomy under climate risk disclosure, which whether sustainable reporting will be part of it. We will see investors reporting from end of 2022 in a mandatory fashion about their assets, and the taxonomy is the framework to report. So at the minimum, this will drive a normative, Europe will have a normative role in driving common standards around the world, subject to any discussions that we have with other countries in the meantime to harmonize taxonomies.
Sean, there's an interesting question from Motoshi Tomita
Go ahead.
coming in, how we define the boundary of the systems on the transmission thing. And it's something we also discussed a lot. And the boundaries are effectively top down. So if you can define a very large system, like a transmission system operator, or even a union of multiple regional system, as we have done in Europe, then effectively all subsumed smaller scale systems that are included in that also automatically qualify. What we didn't want to do is put unnecessary burden on small distribution grid operators to demonstrate something which may be outside of their control as well. So if your overall transmission grid or even regional grid qualifies, then all grids contained therein also qualify. However, if they don't qualify, then your smaller regional distribution grids, which might be almost self-contained or might have a lot of renewable generation in one specific area, may also qualify. So it works both ways, and it's inherited top down. So effectively, I hope that answers the question.
Great. So I might move on to the next slide, if that's okay. But do remember that this is a vast area of CapEx. If you're a green bond practitioner, someone in a debt capital market team, there will be a lot more green bonds tied to this in the future than we've seen in the past, which has been a narrow slice. In the other sectors we've looked at, cogen, district heating. Karsten, can you cover a couple of these for me on this page? And then we'll let John chime in after you.
Yes, very happy to do so. So if we look at those examples mentioned here, maybe I give it a start with storage, because I think it's a pretty interesting piece that is critical for the way forward, in particular integrating renewables into the broader system. So in that respect, storage is in principle if we look at electricity storage, say everything, and that is very easy to digest, is what would qualify for the taxonomy. So there was quite some discussion about storage of hydrogen. So there it's a little bit, let me say, we have to distinguish between different activities. So, for instance, when it comes to construction of hydrogen storage facilities, so that would be included in terms of CapEx. So when we look at operating hydrogen storage, say that would be included only if hydrogen would be manufactured, if you want, in a green way. So green hydrogen would qualify for the operational expenses.
So the same threshold applies for hydrogen as any kind of electricity generation, 100 gram, right?
Yes, exactly. Say when we look at production, so that's a different issue. So when we look at storage, say the idea here is very clearly, as I mentioned, integration of renewables in the grid will require storage at large quantities, and in that respect, we think in the taxonomy and the TG that that should be included under the taxonomy as much as possible.
And of course, John, to you, the pipeline network is tied to that hydrogen story, isn't it?
It is. I mean, ultimately, we have huge pipelines, gas pipelines in the ground today, and not all of this will be needed in future. Some of it will be, and it really depends on how quickly we can shift the use of currently natural gas to low carbon gases, be they biogas or hydrogen going forward. Now, again, what we want to support is the conversion of the gas grid to the green gases, but for that, we were already insisting on that there needs to be a credible plan going forward, and that any renovation or any current maintenance of gas that even wants to qualify needs to basically be linked to an integration of low carbon gases going forward.
We've actually seen a bond already issued claiming adherence to taxonomy. A few weeks ago in the UK, Covent issued a bond with a mixture of assets, renewable energy and so on, but also pipelines that they claimed, and they're verified, DNVGL confirmed in an independent report, met the current EU taxonomy. So it started even before this has gone into regulation.
No, and that's good. I mean, that's the intention. I mean, we want to provide guidelines. We don't want to block all of these investments, but we want to provide a clear way for them to assess on whether they're part of the solution or part of the problem, so to speak.
We'll come back to hydrogen in the manufacturing sector, where we've got a manufacture of hydrogen aspect to it. But you can tell from our conversation today, we believe green and blue hydrogen, blue, we're using gas and CCS, are going to be a big part of Europe's future, with an emphasis on trying to grow the green, but there are cost structures and there are challenges, and this is going to require some work between government, the industry, and potential producers, including outside of Europe, in growing the sector. So there's work to be done, but it's very clear what the destination is going to look like. Let's have a look at the cogeneration and then the heating and cooling aspect. So, Karsten, can I get you to kick us off on this question?
Yes.
What are we trying to do?
Yeah, so we try to do to be as straightforward as possible, knowing that there's quite a few challenges in those areas. So with respect to cogeneration, the treatment of heat and electricity, so we discussed different ways of treating those that are clearly different. In the end, we came to the conclusion that the easiest way, though not perfect, would be to apply the same 100 grams threshold for combined heat and electricity production. Again, and that's mapping the power generation part, reducing every 5 years going forward. So, yeah. And maybe I just add a few words on district heating and cooling. Again, 100 grams here, and the reference to the EU Energy Efficiency Directive, so that you can see on this slide. So it's an important part in many cases, in particular in urban areas where district heating is one of the technologies that is increasing in terms of application. So it was not the first and highest priority we looked at, but then in the end concluded, okay, it needs to be part of the taxonomy in the first place, and came up with this proposal to the Commission.
Karsten, it may be worth explaining that the logic for district heating and cooling is similar to the one we had for transmission distribution of electricity.
Yeah.
I mean, ultimately, we're trying to promote the network first, and that's what you normally do, and then deal with the generation separately. And it needs to be said that the 50% criteria only applies to pipelines in the ground. Heat generation assets still needs to meet 100 gram thresholds everywhere. And that's, so again, gas-fired CHP might be contribute to making your district heating network infrastructure eligible, but the CHP itself would not be eligible because it's basically helping you get started on your entire thing, but it's not considered part of the long-term solution. And your district heating can decarbonize over time, whereas your CHP plant, once it's there, is always going to have the same emissions.
What about if you've got a CHP plant with multiple inputs, such as waste heat, multiple boilers, and so on? Is it complicated to be able to figure out how you qualify under that scenario?
I mean, ideally, you'd have as many, you'd divide it into discrete components. If the individual components qualify, and if they can be separated clearly from an industrial and commercial activity, then you should always look at these separate commercial industrial activities, even though they might all be on the same site. However, if they cannot be separated and there's an integrated part where you say you have waste heat recovery with a backup gas-fired boiler to cover those periods where the waste heat might not be there because you have an intermittent heat source and so on, this is basically an integrated system that you would have to then look at as a whole, on a whole basis.
Now, this is cooling as well, folks, because in the last few years, we've seen some very hot weeks in Frankfurt, Karsten, haven't we? Temperatures are rising in summer. This is again likely to be the hottest year on record around the world. We're going to have to establish cooling systems in more parts of Europe than just around the Mediterranean. In Shenzhen, where I was recently, in the free trade zone, they've introduced multi-block cooling systems where one plant serves 3 whole city blocks. The energy use is 1/3 what it would be otherwise for building by building air conditioning systems. Same principle. The pipes, the ducts would qualify, and then we have to look at the actual energy that's being generated and what the threshold is, whether, however it's come from. It's coming from renewable energy or other sources. So similar principle is cooling as well as heating going forward. Very important for the world we're unfortunately creating for our kids. This has been a bit challenging when it comes down to the bioenergy side of it. We've had a lot of discussions, and we're still having people coming to us and saying we need to do this, X, Y, or Z. In the end, what have we settled with? John, can you give us the summary on the bioenergy criteria?
Effectively, we've linked it back to the European recast Renewable Emissions Directive in a nutshell, and basically saying that only advanced feedstocks listed in Annex 9, so the advanced feedstocks, are eligible, and only if they have emissions savings compared to the baseline fuel of at least 80%, which is a bit higher than the, a bit less stringent than the 100 grams on a life cycle basis, but is actually quite easy to determine, whereas otherwise because it makes use of an external reference, and it was felt that forcing a full life cycle assessment on every small biogas project was not technically desirable or even feasible, and that would have completely blocked the whole bioenergy sector from being eligible. So linking it back to RED 2, which is a requirement, ultimately a legal requirement today, and is an existing legal framework, at least in Europe, should make it relatively easy to implement.
With a carve out for some forms of inputs is the key thing to know. Yeah. We would probably say, this is not formally in the TEG report, as individuals, that RED 2 needs some work. It needs updating for the current approach and the current targets. And I'm very hopeful that the Commission will tackle that issue over the coming year to make it more in line with our new climate targets. But it is there, it's what we have in place, so we provided a guidance around that. I'm going to move on to carbon capture and sequestration. And Karsten, maybe you can, in fact, I'm going to leave you out of it because this is a bit controversial in Germany at the moment. I'll let you dive in. I'll let John come in first. but I will say that we did agree with the modelers that it's very difficult to see how we get to our 2050 net zero carbon without some form of carbon capture and sequestration. And the important thing for listeners and viewers to understand is there's not just one kind. The bad press has been tied to particular models. The bad press may be unfair, but there's actually a lot of different models. I had this fantastic demonstration in Reykjavik in Iceland recently, where Reykjavik Energy is capturing emissions of geothermal, because they want geothermal to get to net zero. They're putting that in a water solution, burying it in young basalt, as they call it, and it mineralizes in 6 to 24 months. It turns into rock. I've got a bit in my briefcase. And I'm thinking, well, that is actually a pretty solid sort of sequestration, right? But we're not favoring any particular form of technology. What we're doing is setting some rules. And it's technology agnostic. It will be part of the mix. If you bolt this on to another plant, it doesn't mean the other plant qualifies. It means this infrastructure qualifies. But if you bolt it on to an electricity plant and you get the electricity plant, gas generation, below 100 grams, well, yes, then the whole thing can qualify. But let's just dive into this. John, tell us what the hell this means.
I think we need to distinguish, first of all, I absolutely agree with you that there is very little chance to reach the 2050 targets without revisiting CCS. There was a big hype about CCS in the early 2000s, and it sort of died down a bit after that. There were a lot of pilot projects, many of them sort of never happened. I think this is fine for the power sector. We'll need to revisit it. I think it's equally important to keep in mind that this is not just a power sector issue.
Absolutely.
That in particular, there are significant savings that can be made in the manufacturing where there are no other options. There are no renewable options or limited or expensive renewable options. So a revisit of CCS as a whole should happen. When we then look at how we implement it in practice, and when we looked at it also from the taxonomy, is how do we deal with this, and how do we in general accept it? And you've already put out the outline. Effectively, we distinguish between two types of infrastructure. First is the common infrastructure for getting the CO2 from wherever you've been capturing it and storing it underground, which is not likely to be a common infrastructure, shared public infrastructure or commercially operated infrastructure, but that will be under one actor. And then there's the capture, which is typically under the responsibility of a particular industrial or energy generation activity, which then has a contract with whoever stores and monitors the actual storage infrastructure. When we talk about CCS, we mean this whole chain, but effectively it's important to distinguish that the capture part is the part that links to your plant. As you just explained, if I have a gas plant, I capture 90% of my emissions, I'm well below 100 grams, and I have a contract with somebody to take this off and store it somewhere safely where it doesn't create significant harm, coming back to the other pillars. And also coming back to, maybe Karsten can expand on that, some of the reservations we had when we first discussed this in the risks. And as you rightly say, there are multiple ways of storing it. Then this makes the underlying activity eligible. If you don't do it, and if you just retrofit something, you install the capture, then the capture installation itself may still be eligible because you're significantly reducing emissions, but it doesn't make your underlying gas plant eligible if you don't get it to 100 grams.
Karsten, do you want to add to that? John's thrown up something for you.
Yeah, so, no, what I can add is that so we have been well aware about the risks that are out there in terms of application of CCS. So we know about the hesitations. We had intense discussions with those with some more experience, say engineers, and came to the conclusion, and that's very much based on IPCC and then the overall perspective, that looking into CCS is unavoidable. It's very important to operate CCS operations or plants, if you want, in a very decent way that is according to standards. So there's quite some stringent standards mentioned in the do no significant harm part. And that should at least provide sufficient safeguards to operating CCS plant. But as you just mentioned in introducing this very topic, it's very clear that it's a contentious one, where there's some movement, as far as I gather, in different parts of society to at least become a little more open to CCS. But I think there's a way to go, and it's basically, but that's my personal statement, it's a credibility issue in the end that has to be proven.
Indeed.
And I think the question just came up on what about CCU, carbon capture and utilization?
Good question.
This was discussed, and again, it's even more controversial than CCS in a lot of ways, because it can cover such a huge range of potential activities. I think it's not specifically included, it's also not specifically excluded.
Yeah.
If you can make CCU work under one of the manufacturing streams, for example, by reusing the carbon and producing your manufacturing good while meeting the manufacturing thresholds, I don't think anybody's going to object to that, but CCU in principle isn't eligible. It is a topic that has been referred for further analysis, I think, to the platform and for something that should be monitored on a case-by-case basis. And certainly in DRB, we've seen CCU projects linked to the manufacture of biofuels, which we have historically seen as positive, but we've also seen CCU projects where effectively we were just putting a slight time lag in the emissions, which wouldn't have been eligible with no additional value. So it's very complicated, this topic that unfortunately the technical expert group wasn't able to cover fully.
Thank you. We need to move on to do no significant harm. Karsten, I'm hoping you can give us a bit of an overview of this. There are a lot of provisions that we put in there, right? Do people need to panic?
Certainly, this is an area that that has its challenges to be applied, depending on your respective perspective. Say, there's incomplete information right now around, in particular, that area. And then coming from a financial markets perspective, this is maybe the biggest challenge to evaluate. And then can't be done from my perspective without further information and deep dives to get actually on the asset level. And the information has to come from somewhere in order to be able to look at this. But there's one overriding principle that may make it a little easier. Say one of the overriding principles was that what falls under what is in sync with European regulation, that is fine. So and thinking about installations, infrastructure within the European Union, then it can be subsumed. Okay, so no significant harm is done. So that makes it, I hope at least, slightly easier. But in any case, so when we look at the other areas where do no significant harm requirements apply, then it's the remaining 5 environmental objectives of the European Union. So some of them are mentioned here. In particular, adaptation is one very important. I've seen one question earlier on adaptation relating to the energy sector. So that is covered under the adaptation bracket. So Jean, you have to tell me if this is covered under a different webinar. Likely yes.
Yes.
So I'm going to park this for now. Say, what is and adaptation is maybe quite an interesting part here. So if the activity in the mitigation pillar would adversely affect adaptation efforts, no? Like it's mentioned here. So this is a very easy example to understand what it's meant looking at DNSH requirements. So it's always kind of a call for looking at a holistic perspective that physical risks are minimized to the extent possible. So I think that goes without saying for everyone in the industry. So it's maybe calling for something that is already there, but it has to be on paper. And in that respect, as it's part of the regulation, so we had to tackle this.
I mean, essentially, there's a bit of common sense that's required here.
Yeah.
If you're building a piece of kit, a large piece of kit or infrastructure in Europe now, and you're not considering adaptation and resilience measures, all these other measures, frankly, you're being negligent. So we just need to normalize that. We haven't set a particularly high bar, and there will be a whole separate webinar on adaptation and resilience and so on. There is not a high bar on the detail of what you have to do. It's a best effort basis. And if there are recommendations, you have to act on them. That's what we ask. If you haven't done an adaptation resilience report, then you're in trouble. You've got to get one done. Now, this isn't going to be applying if you do a biomass plant in your backyard, clearly. There is a common sense aspect about this. But in this sector, we're talking about significant investments at scale where it's absolutely essential that we consider these issues given Europe's climate and the world's climate is in a state of rapid change. Heat is going to become much more of a problem. Coastal storm surge, you know, sea levels rose 2.2 centimeters last year because of the ice melt. We're going to get storm surge. We're going to get all sorts of things happening in the future. We just got to start preparing for it. That's not too much to ask in principle. And we've got to learn how to do it though. And that's why we can't set very strict rules about how to do it, although our adaptation experts will give us more guidance, because it is a work in progress in many sectors. But of course, there's guidance, the Commission putting out guidance, and there's a whole body of consultants in this area with fantastic expertise to be included in these discussions. This is a disclosure requirement. The investors that want companies or assets to report against this will be expecting you to show credible reports around these measures. That's essentially it. And the bulk of do no significant harm is covered by regulation in Europe. We put it in there for guidance for other countries because we are looking for people to tackle these sorts of issues globally. It is a work in progress. That is, I'm sure we can to adjust things to get it right. The balance between what we need to do and practicability is a tough one, right, Karsten?
Yes, exactly. So there was one question that I found pretty interesting. So it's not relating exactly to do not significant harm to mitigation, but to adaptation actually. So when we look at that relates back to energy. So so there's different thresholds appearing, and maybe that's worth mentioning, Sean.
Yes, that's a good point. But look, we need to wrap up, would you believe? 1 hour goes in a zip when you're having fun. And folks, this is a deep and rich report. We will attempt to address your questions, in some cases by email response, but otherwise we will be advertising to everyone who's participated in these webinars a forthcoming Q&A page that picks up a lot of the questions. That's how we'll tackle it to make it as efficient as possible. We're at the end. John, any last advice that you would give people in this area?
No, just keep asking the questions, I think, is the main point at the moment, because we've been in our own technical expert bubble with a large public consultation, but now we actually have to start using this this process. And I think the real challenge is, if you see things are definitely not going to work or are going to be too complicated or too costly for certain actors, please flag it. I mean, and refer it back to the taxonomy or to the group, so that it can be tackled by the platform in a next iteration if it's simply not feasible, and provide feedback, not necessarily on the content, but on the implementation of what has been done.
And is the EIB using the taxonomy?
Yes, we're doing exactly what I've just been saying. We're looking at the taxonomy and comparing it with our current procedures, which are already in place. I mean, as you rightly pointed out in the beginning, we've been doing green bonds for quite a while, and we had reporting requirements and standards in place, which have informed some of the discussions in the technical experts group as well, because obviously we've been an active part, but they haven't been transposed as per se, and a lot of other viewpoints were also included. And we now have to go bit by bit, line by line, saying, are we doing enough to really be able to say that we're complying with the taxonomy, and where do we need changes? And that's, I think, the main thing. Look at existing processes. If you haven't built any processes yet, start thinking about how to put processes in place to ensure how you're going to monitor and verify and confirm eligibilities. And if you already have processes, at least do an audit and see, well, what might you have to change?
Karsten, it's been a learning process for you and I. What would you share with people?
Certainly, it's a great learning experience. I think for everyone dealing with that issue, and it's maybe to some extent a surprise that actually there was a result in the end that I think is a very good starting point to build on further work. So there is certainly further work to be done. But maybe linking it back to the current crisis and to fiscal policy and investment support that is likely to come from governments. It's maybe a useful tool, even for that, in order to see, okay, how to do two things at the same point in time. So to start the transformation towards the climate goals, and to achieve those by 2050, and at the same time to kickstart our economy again. Great point.
We are about to enter a period of thinking about recovery. We're in the midst already of a recession, a very severe one. It's got a way to go yet while we're in lockdown. We know, we've already agreed at a political level, we have to stimulate our economy. Germany's made some astounding commitments to invest up to 4% of GDP or make it available as stimulant funding, for example. And that's across Europe and many countries around the world. We need to make sure it's green. We need to ensure that it creates the future we need, not the past, not what we had in the past. And that's an opportunity, a silver lining of this difficult time we're in. The taxonomy is a framework for the future. Help us make it real. Thank you everyone for joining us today. Thank you to Karsten and to John for taking time out to explain. We will continue to be discussing this. You are so lucky because you get an opportunity to join us at 3 p.m. Central European time every Thursday until June to talk about a different part of the taxonomy. And we will record all of these and make them available as podcasts. So remember, if you didn't catch something properly today, you'll be able to download this, listen to it again, to Karsten's wisdom and John's thoughts to make sure you fully understand. But of course, the download of the report is showing on your screen now if you've got it available to you. And if you want to sign up for the others, climatebonds.net/webinars. Thank you again for joining us today. And thank you for your interest in making Europe a more sustainable place and making the world a more sustainable place for our children. Thanks, everyone.
Thank you.
Auf Wiedersehen.
Stay safe.
Bye-bye. Take care.